Hello, today we're going to be talking about cubic functions. A cubic function is a function where x is being cubed. A cubic function will look like this. I shouldn't say normally, but I shall say this is the most common type of graph you'll see for a cubic function. But this is also prevalent, and you can see that type of graph too, but you will see this type of graph in our example today. So you might be wondering how to do a cubic function graph, how to graph it exactly. Well, it's quite easy. So to start off, you're going to have to think, what value of x will make this part 0? So you might be thinking, well, 4 as x will make this 0. And you are right. So you're going to know that it's going to be somewhere around the 4, like x equals 4 line. And you know that's going to be your vertex. That's going to be your first coordinate in your vertex. If you don't know what a vertex is, we'll get to it, but just hang on for now. And then you solve the equation. You get 4 minus 4 is 0, 0 cubed is 0, 0 times 1 is 0, 0 minus 8 is negative 8. So you're going to go down to 4, negative 8, and you're going to plot your first very, very important point right there and plot it. And you did that. And the next thing you're going to do is that you're going to go either one space to the right or to the left. I'm going to go to the right in this case because it's going to be easier not to deal with negative numbers. But it's your choice and you can do whatever you choose. But we're going to go to the right in this example. So we have 5. So we're going to do 5 minus 4 is 1, 1 minus 1 to the third power is 1, 1 times 1 is 1, 1 minus 8 is negative 7. So you're going to go and you're going to plot that point right there. So, as we talked about earlier, we know that our vertex is going to be located on the line of x equals 4. And now we're going to learn what a vertex does and how it's so important. So a vertex is where everything happens. It's the point where the line of symmetries get rotated or whatnot. It's the point. Sorry, my bad. It's the point where you have your symmetries. It's the point where everything gets reflected. In other graphs, it's the point where it's the point that's like the last point, and everything from that is a line. It's a ray. Vertex, I like to think of it. Sometimes in other graphs it's a ray, but for here, it's kind of like our little portal. It's our very important portal to go to a different world. So I like to say that it's where everything gets reflected back. So it's like a cool portal. And we know that we already have a point that's like one space up. So we're also gonna know there's gonna be the same point one space down. I mean, how cool is that? It's like half the work. I think it's pretty cool. And you can even check it if you do plug in 3, and you're gonna have 3 minus 4 is negative 1, and negative 1 cubed is negative 1, and negative 1 times 1 is negative 1, and then negative 1 minus 8 is negative 9. And look, it's like negative 9. And that's You don't have to do the work, but it's like one of the tips for cubic graphs. And then I'm going to go to the right one space, and I'm going to have 6, and I'm going to do that. 6 minus 4 is 2. 2 cubed is 8, and 8 times 1 is 8, and 8 minus 8 is 0. So I'm going to plot my other thingamabob here. And as you see, it is 7 spaces up. So you're going to have the same 7 spaces down. Of course, it's going to be off the graph, but that is okay. And as you see like that very distinctive type of left graph of a cubic function. We can go one more space to the right and plot another point, but that's going to go way off the graph. We're going to get 7, 19, and we just don't have enough space for that. So we're going to go ahead and start connecting the lines. And I think this is like the most hardest part of a cubic graph. Mostly because you want to make it look curvy. Like, it needs to look like a twisted parabola. And you always have to keep that in mind, because that's important when you are making your cubic graph. I mean, this would look much more nicer if I had a straight edge, but you've got to do what you got to do. Oh, sorry, my bad. I'm sorry if this is kind of really glitchy, because yeah, I'm using Google Keep, and that's cool. Okay, before we move on to any of the other stuff, I want to talk a little bit about what this is. So, in vertex form, you're going to have something called A, H, and K. It's going to be the same for every graph out there. Well, mostly every graph. Just, it's going to be the same for cubic functions when they are in vertex form. And it's always going to represent, A is always going to be steepness, H is going to be moving it right and left, so along the x-axis, K is moving it up and down along the y-axis. And let's talk about A for a little bit. A is going to be outside the parentheses of x, and the bigger it gets, the more steeper it will become, and the smaller it gets, the more broader it will become. So, and then H is going to be moving it along the x-axis, and it's always going to be opposite. So you need to remember, when you have H, if it's going to be -4, it's going to be to the right 4 spaces. Not to the left, but to the right. And then K, it's outside the parentheses, and it's going to be moving it up and down. And if it's negative, then it's going to be moved down negative. And if it's positive, it'll be moved up positive, like how many spaces. And you can see that on your graph, because it's like the vertex that's being moved around. So like usually the vertex, I guess, will be located. It's like in relative to the vertex being located at 0, 0, the origin. But, you know, it's moved to the 4 and down, -8. And you can, like, that's something that you can tell right away without looking when you get better at these type of graphs. Okay, to the fun part. So, let's talk about domain and range. If you guys don't know what domain is and what range is, domain is like the x values, and range is the y values, or f of x, or whatever is going to be here. So, the cool part about cubic functions are that domain and range are always going to be all real numbers. And this is this is how you have to This is function notation, and this is how you have to write it. So you're gonna write it cool curly brackets, and you're gonna put x, and then this is an absolute bar. It's not an absolute value bar. I'm not sure what its real name is, but I like to call it the absolute value bar because it reminds me of one. It's a line, and it's gonna be, you have to write all real numbers for a capital R. And we already talked about symmetries, and it's always going to be diagonal and rotational because you can move it. Because when you it's diagonal because it's kind of that's really bad, but if you had a mirror, you'd literally be reflecting it off the same. And then it's also rotational because you can move it clockwise and you would get the same. And that's pretty cool because that's cool. It's like the vertex, it's our portal. And we already talked about our vertexes, but it's going to be, as you know, 4 and -8. And then if you get asked what the asymptote is for cubic functions, you don't have asymptotes, but for other functions you will. But just for general knowledge, an asymptote is when your graph is gonna try to be approaching something. So for exponential, it's gonna be trying to approach something along the x-axis. But we don't have that, luckily, for cubic form, so you're gonna be put literally none. And the fun part, so y and x intercepts. They're really not that fun, but they're fun-ish. So for y-intercept, you're gonna have to it's gonna be 0, comma, blank. Well, you're gonna have a value for that, but I'm just saying. So you're gonna put in 0 for x here to get our y-intercept, and you're gonna get 0, -72. And then for x-intercept, you're going to get something, comma, 0. And it's going to be located along the x-axis, and it's the same for y. It's going to be on the y-axis. And lucky for us, usually you would put a 0 there and you'd solve it from there. And that's kind of hard. It's kind of tricky for cubic graphs, but luckily for us, our x-intercept is going to be 6, 0. Okay, now we have the fun part out of the way. And this is kind of fun too, but this kind of gets you kind of have to really imagine for what we're going to talk about next. And we're going to be talking about end behaviors. And it's a really cool thing once you get it. And you get to draw infinity signs. How cool is that? It's actually pretty cool because infinity signs are awesome. So before we start, I'm going to go ahead, I'm going to label. This is infinity. This is negative infinity. This is infinity. And this is also negative infinity. So end behaviors, it talks about the graph. So when you write end behaviors, you're going to need to write, for cubic, you're going to have 2 x's. I don't know if that makes sense, but you're going to always I like to think this is the format. You're going to always have these two type of, you're going to have x, as x is approaching infinity, f of x is approaching blank, and as x is approaching negative infinity, f of x is approaching blank. Okay, this is gonna, you guys have to be ready. This is gonna blow your mind. You might be confused like I was for a couple days, but it's okay, you'll get it. So you have to think, as x is going to the right, what is y doing? And you can see that y is going up. So y is approaching infinity. And as x is going to the left, y is going down. So it's approaching negative infinity. You guys might be really confused, but infinity for x is right, so it's going to be moving to the right. And negative infinity is left. And relatively up is infinity, and down is negative infinity. So, you have to, think of it as a whole. It's kind of hard, it's hard to catch it, but when you do, it's the easy part. And, I think I was confused on this when I was kind of doing this. It's going to be when you're going to the infinity, it's going to be above this line. You're not looking at this, where it's here, but you're going to be looking here. And, you think, is it going to the right or is it going to the left? You think, as it's going to the right, where is it going up? Is it going up or down? So that's what I like to think. And it's actually fairly simple. And this is basically it. This is what a cubic function looks like. These are some easy tricks, like domain and range are always going to be all real numbers. Always going to have diagonal and rotational. You're going to have a vertex, no asymptotes. Vertexes are a little cool portal. And this is a vertex form. It's going to look like a twisted parabola. And that's what it is. So I hope you guys had fun. I hope this wasn't that hard and I explained it fairly easily. And yup, this is it.